All right, hello everyone. Welcome to the Landtamer stream. We are building our own home lab here. Not doing a workbook tonight, but we're actually working on some technology, convergence technology, and continuing from last night. So let me pull up the agenda for you guys and the chat and all that other good stuff so we can collaborate if you'd like, or if you want to comment or lend a hand, that's always welcome because I certainly need it from time to time. By the way, this is a Star Wars, kind of illustrating the special effects. They got nominated today for Oscar for several categories. Happy to see that. They didn't get snubbed this time, and they shouldn't. Very good movie. But yeah, we are continuing on the Homegrown Convergence Lab, and just a couple of topics to talk about. The Twitch dashboard. I think I've got this sort of straightened out. So I moved these little tiles around so now I can see viewers and everything, and even video preview there, which is cool. So starting to figure things out on this little Twitch platform. So that's good. And convergence optimizations. I don't have any meat chunks to talk about today. It was a busy day. I did put some, I may have put one or two in Discord, but I did not have any time today to really look at any kind of, not even on breaks. But yeah, let's get right into this convergence lab. So just tell you where I am in general. In the INI workbook is my primary study method, and the INI videos. That's kind of my curriculum, right, for studying the CCIE route switch. So I've gone through, and in the natural sequence of videos, there are no labs for this convergence optimization. There's 5 videos, and I got through, I'm almost at the end of video 5. So yeah, I've covered a lot of the topics, and yesterday it kind of inspired me to do my own lab, which I've been wanting to do for a while, just to get a little more, a little rusty and viral. So, and there's some things, kind of scenarios I've been wanting to play with anyway. So we started on it last night. It took a little while. I think I left for about 2 hours yesterday, and I got pretty far, but I made a little bit of progress today. I picked at it today, and I've already got it running. So I'm using a combination this time of, in viral, let's talk about viral just a little bit, and building your own labs in viral. I had a few issues yesterday because I didn't really start correctly. And if you don't click exactly right when you're trying to create a project, so in other words, if I stop this simulation, like the advanced technologies is the one we use for all the INE labs, but if you stop the simulation, if you don't click over here, you have to be real careful when you click and then just start editing. So twice today I went through the advanced technologies labs topology, and that's okay. It's not gonna, I think I have to double click it for the topology to come up here in this view. But twice I went through and renamed all these routers. I added an 11th router, and I saved it only to realize that I was not editing the new topology that I'm trying to work on. So that was a little caveat, but we basically took the 10 router simple lab, added an 11th router. That's what I was missing yesterday, is an 11th router. But we've got that all built. We've got the routers renamed in the topology. And so when I bring up the terminals, we saved all of our configs too from yesterday, which is great. So yeah, my terminals come up. It looks like sort of in a alphabetical order, I guess. You know how you do telnet port 17,000, 17,002, etc. Apparently Viral does these, orders them in alphabetical order. Let's see, MN, what is this one called? V, yeah. Which is good to know. I did not know that until today. But yeah, we've got them loaded up here, ready to go. And let me talk now about, let me pull up my notes about what we're trying to accomplish here. And I've been thinking about this on and off all day, right? You know how you let an idea sort of gestate, and you at work sometimes we call it shower time. You're thinking about it. I actually last night, guys and gals, I actually several times woke up dreaming, or at least thinking. I'm not. It's hard to tell sometimes the line between dreaming and thinking about something in the wee hours of the night. I could have swore I was dreaming about this lab, and it's kind of been. I've become a little obsessed with it. So, which is cool. It's great. I'm really excited about these protocols that I'm learning, and I'm feeling really. Some of these labs you do, and you trudge through them. It's hard to get excited about some of these protocols. But in this particular case, some of the things I'm working on here, I'm excited about it. I'm really excited about getting it working and testing some of these scenarios. And I'm even dreaming about it. But here's what as I've been kind of gestating on this, thinking about it. This Convergence test lab, I didn't want to be too aimless. Yesterday, I just kind of started kind of pasting in some configs and hacking away, right? Normally, I like to do Notepad. I like to pull up Notepad. I like to put all my configs in Notepad first and paste them in. That's how I envision doing it in the real lab exam. Why did I not do that? I just started punching away, which is okay. This will likely be a throwaway lab at some point, or rebuilt. But I want to continue the build, and I have a diagram here. I polished this diagram a little bit today. Like I said, I did not have a lot of time. Let's find it, though. Let's see. I think it's a PDF. Thought I had it pulled up here. No, I don't. All right, let me show you this topology. Let me find it and show it to you. Oh, wait a second. There it is. Got a lot of windows open, guys. Okay. So as you know, you saw this yesterday, a version of it. And actually I need to make, there's a couple more changes I need to make real quick. I use the template that has their company logo on it, just out of habit. I have sort of a template with a bunch of shapes I like to use, but this has nothing to do with work at all. Okay, we got rid of that. Yeah, I need to fix that tomorrow. But anyway, so yeah, I have now this topology, and again, it's not perfect. For example, I'm going to point out a few things, and maybe we could do some edits on the fly here that I'm just going to have to correct later. But so really, BGP, it's not going to work in preview. BGP 65504 is all three. I added this router, so now we have sort of a, for lack of a better word, a core. Let's say this is a data center router or a core router, whatever you want to call it. And then you've got two paths, you've got two links, and this is all one big BGP area, AS, same AS 65504. So we're going to do iBGP here. That's new, and I need to check that. And then really BGP 65504 is not extending to this router, right? So we're using a Verizon MPLS cloud here as an example, and this is AS1. And we have a single route reflector. And again, the same thing here. Really, this, we'll call this Miami, the remote site. And this is a BGP area that these are individual boxes, but only one router is in this area, right? Miami 3, for example, is not running BGP. So that is one difference here. But all in all, we need to just kind of carry on. I'm going to make a note here, actually. So this really is, let's use a color here. Really, this is BGP 65504. And these routers are not in that area. So let's do green. It doesn't really matter. Pink, let's go with pink. Why not? This is BGP here. I will fix this, folks. I do have Vizio on this PC. I actually have a virtual machine, but it takes a lot of resources to run on this box. This Mac is the streaming computer and the lab computer at the moment. One day that may change, but right now that's what we've got. So this really is your BGP 65504. So we're doing iBGP between all these three routers, and then eBGP here to our MPLS cloud. Okay, so let's just check that. And I've created a bunch of loopbacks here and here, of course, kind of arbitrary loopbacks. I put an aggregate route in there. So let's just make sure that that is running. That's where we're at now. So yeah, let's back up even a little bit farther than that. So we need to continue this build of this topology. And then we need to validate the build. We need to validate BGP. Okay, so let's just write this out, right? BGP in New York. EIGRP in New York. Routing between sites. And then we want to see ECMP. Well, we'll say Miami to New York uses ECMP routing. And the way we're going to accomplish that here is we're going to do, again, just for simplification, these are going to be redistributing BGP into EIGRP. So this is our build scenario. Then we're going to validate the build based on the requirements we have up here. iBGP in New York, right. Okay, let's do it in this order. And the purpose of this is to, in EIGRP, we don't want to do redistribution here. So we're going to get routes from Miami through the cloud. And the way we want to distribute these routes is not from redistribution of BGP into EIGRP, but we want to redistribute the routes via, or advertise the routes via iBGP, the external routes, right? And we also want to, of course, for iBGP to work, we want to assume that we have an IGP running with reachability to all the routers and links internally. That's why we're going to run EIGRP here. So we're going to run EIGRP and iBGP. Pretty standard setup, right? And down here on these routers, we're going to run BGP, eBGP, and redistribute one way into EIGRP. I believe it might be mutual redistribution. No, I don't think it is. So it's one-way redistribution there. And that's how we're going to get reachability. So by the end, we should have reachability between the loopbacks at the main office and remote office. That's what we're going to call Miami. Validate the build, and then we have these problem statements. This is the whole purpose of doing this lab. And that is, we're having issues with convergence. Summary. Having some reliability issues with MPLS provider links. Occasional outages are of a single provider . how do we state this? So we have reliability issues with the MPLS provider. That's a problem in and of itself that can be addressed in various ways, right? But I need to check something. I just thought of this. Okay, Nightbot is in the stream. Good. So we have reliability issues with the MPLS provider where, obviously we can't just switch MPLS providers from one day to the next. We have to, even if we were to order new circuits, right, switch providers, it's not going to happen for a while. And in the meantime, we're having issues, right? And issue primarily, so we can say reliability issues with provider, occasional outages at remote site. And it's not all users, but a large number of them. Causes some applications to crash. Users must restart. Some applications to crash, calls to drop. Okay, so that pretty much summarizes what's going on. So what management, the management challenge, let's even make it more dramatic. Management has challenged the network team to better leverage redundant paths to minimize impact of an outage. And that leads us to convergence, which is what we're studying right now, right? So then we have our technical analysis. And we've come up with some problems, right? One of the problems is that we have seen is this peer link. We're going to pick on this side. That from time to time, we lose a peering session here. And the hold time expires, and half of, we're doing equal cost multipath traffic here, algorithm, and half of the links will drop, half of the sessions. And it takes a long time for them to recover. That's one problem. And that is sometimes a direct physical link failure. Not in our link. Our link shows us up, but in the intermediate equipment between this router and that router. Scenario 2, we have suspected. Actually, we're not going to worry about that. This is really more a summary of what's happening. Okay, scenario 2 is we fear, and we can only suspect based on feedback that, call the vendor, call the service provider. Apparently there are issues with this router and its link into the cloud. And there is some flapping or maybe a process or software problem that this routes are lost this way. And we never detect it. So a lot of packets are dropped until convergence happens with the provider's cloud. So we need to come up and propose some solutions, right? And we'll get to this later. I have a number of comments on this and things that we can do. But first, we got to go back to our first task, right? Which is to continue to build out with these requirements in mind. All right, so I think EIGRP in New York, that's what we need to check right now. I believe that is built. But let's look at New York routers 1, 2, and 3. Okay, so if we do a show run section EIGRP, okay, so as you can see here, if I do, we've got, I created quite a few loopbacks on this. So we have, for example, our, like our loopback 0 is 192.168.3.3. And then we've got some 10 networks here, 192 networks. So I just kind of randomly created. And I wanted to have an aggregate address too, so some of these are going to fall under an aggregate address in BGP. So yeah, we have the, now one thing I think I need to fix here. Show IP BGP, no, show IP EIGRP neighbors. Yeah, I don't really want, yeah, now he needs 2 neighbors, but what's happening is we have a triangle, and I don't want a triangle here. I want a deterministic, I want deterministic links. Right now, this guy is becoming a neighbor with this guy. We don't want that. So I need to create separate links here. So let's give these different numbers. We're going to say this is, let's see, 3 to 1. Yeah, why don't we do 1? Can we do 301? Let's see. We're going to do no interface GI 0, 1, 109. And we're going to do a interface GI 0, 1, 301. Okay. Cool, that works. Incap.1Q301. IP address. What do we do for IP addressing? 192.168. Let's do 168.103.3. We'll do 24s. Okay, that's going to go towards from 3 to 1. And then we're going to do a point-to-point link. Yeah, we basically had an Ethernet segment for EIGRP when really we want just a point-to-point link for these guys. No shut. So we're going to do interface GI 0, 1, 302, incap.1Q302, 10. Let's see, that's not really what I want to do, is it? 203.3. Yeah, we shouldn't have any overlap with that. No shut. Okay, so let's go over here to show IP interface brief. All right. No interface GI 0, 1, 109. And this is going to be 301 IP address. Oh, incap.1Q301 IP address 192.168.103.1. And we should actually get an EIGRP adjacency there. Let's go to NY2. Show IP interface brief. Okay, we're going to actually no interface GI 0, 1, 109. Ah, it doesn't like that. I know. And we're going to do interface GI 0, 1, 203. Is that right? 302. .301, yeah, and 302. Incap.1Q302 IP address 192.168.203.2. Okay, so let's check this out. Jet 1.302, 1.302, ping 192.168.203.2. Okay, good. And ping 192.168.103.1. Okay, good. So now show run section EIGRP. We're gonna have to redo BGP as well, iBGP, and that's fine. Router EIGRP 100, 102. Oh, we need to do router EIGRP 100. Network 192.168.00.0.2525. Yeah, let's do that. Thought I had that on there. Yeah, new adjacency. There we go. Show run section EIGRP. Okay, BGP has come up too because we're now advertising the loopback. Show IP interface brief. Do we have any 10s? GI00, we do. I don't think we need that. So I'm not going to worry about that. Yeah, BGP is up now as well. All right. Show run section BGP. Good. Okay, I'm just kind of checking the stats over here. Good. We have 0.4% frames missed due to rendering lag. That's not too bad. The overall stream last night was like, I think it ended up being like 0.1%. So it's a little bit higher. I've got a few other things running here on this computer, but so far so good. Okay. So BGP, yes, router BGP 1, 2.2. And yeah, for our iBGP links, we're doing update source loopback 0. So that's good. All right. So let's just verify our EIGRP configuration. Show IP route EIGRP. Yeah, we're learning quite a few routes here now. And a lot of these are from New York 3. So let's just verify ping 192.168.3.3, ping 10.210.60.1. Good. Okay. And let's go here to New York 1. Show IP route EIGRP. Yeah, we're learning these as well. 2.168.3.3. Now, are we learning? It doesn't look like we are learning the other loopbacks. Yeah, so we have full connectivity here, EIGRP. Good. Now let's check BGP, because BGP should be this WAN router, New York 1, should be learning routes from Miami and injecting those into BGP. Now, what we're not doing is next hop self here. We probably should be doing that. Let's take a look. Yeah, let's take a look at what it's doing in iBGP. So, router 1, show IP route BGP. Okay, we're not learning anything apparently. Okay, show BGP IPv4 uni. State. Now this is, expand this a little bit. No prefixes. Yeah, message sent, message received, table version. Yeah, we should definitely be learning from the MPLS router. But we're not, so that's the problem right now. Okay, so let's troubleshoot that. We're not getting BGP routes. Let's actually start down here and make sure that we're advertising routes into the cloud. So let's go over to Miami 1. I'm not sure how this was left yesterday, so there's no telling. Show BGP IPv4 uni. Okay, we've got quite a few routes here locally originated. And show BGP IPv4 uni summary. Okay. Oh, it says active state. That's not good. Show run section BGP. Okay, neighbor 192.131.33 remote AS1. We have these networks. We have a summary. We have activate. We have a route map MPLS in. Are we running that route map? Route map MPLS in. Permit 10 match AS path 1. That shouldn't be an issue here because we shouldn't be getting any routes into ourself with 65508. But dot star means anything. Or it should. Let's see. Show BGP IPv4 uni. Oh, now it's idle. Okay. Is it just taking a long time? 10 out of 10 paths. 10 network entries, 10 pass 3 using... Okay, let's look at our neighbor here. Wow, interesting. Advertised routes. Yeah, it was active for quite a long time, it seems. And it's active again. So something is going on here. Show run BGP. Hey, yes, good old BGP. But yo, yeah, it's fun. All right, we got remote AS1. Let's just make sure we have reachability. Paying 172. All right, man. Glad to have you in the channel. Hope you're having a good Tuesday. And you're not on call or anything. Hopefully not. Oh, I think I may know what the issue is here. All right, so since we booted this up yesterday, we may not have turned on or left these interfaces up. So let's check this PE router. Yeah, I know, right? That's one thing I learned a long time ago too. Whether you're on call or not, you're always on call. At least if you know half of what you should know, right? People depend on you. All right, this is Verizon Miami 1. And I got a feeling he's not... Hey, we got a new something. I don't get... I don't see those alerts. That's something I need to figure out on... I'm kind of new to Twitch, so... Oh, there we go. Thank you for following. Video, appreciate it. Hope you like the little router. Okay, this is administratively down. That's the problem. I think what happened, guys, is when we were playing with timers, we left our lab in disarray. So we did not bring this interface back up. So let me do that now. That's a problem. Okay, that's our PE router. So we should now, boom, yep. Neighbor, yes, VRF, that's right, awesome. So now let's go over to, let's go back to Miami, and our neighbor's up, sweet. Let's check some of these other routers too. I'm not sure how I left these. So let's just ensure, oh, this one's down too, jeez. Okay, I'm gonna go through now. Let me check the these other routers. Okay, these are all up. And these are up. I'm missing a router here. I am missing a router. The route reflector. He's trying to hide, man. Oh, there he is. Okay, these are all up. Awesome. So now we should have some routing going on, some BGP routes. And let's just back up to Miami 1 first. Let's check him out. IP route BGP. Yeah, there we go. Not much. We are learning. Okay, this is an all 0 because we are advertising in aggregate. And that's okay. That's okay. I just want to make sure I'm actually advertising. I'm not expecting a lot of routes going this way yet, but I should have routes going this way. So show IPBGP uni neighbor. What's 2? 31, 1, 33 advertised routes. There we go. That's what I want. So let's back up now to New York. New York should now know about these routes, at least the PE router, which is NY1, right? There we go. Now let's just look at some of these routes. Let's look at our aggregate. Show BGP IPv4 uni. Actually, all right, IPv4 unit. That's right. This is not a PE router. Show BGP IPv4 uni and 10.45.00. Okay, aggregated. This is best. Advertise to update group at 3, origin IGP, atomic aggregate. Good. And now what is the routing entry for the next hop? Show IP route. AS hops to, okay, cool. So this is external, so I would think that if I have show BGP IPv4 uni, now I should be advertising to my iBGP neighbor here. So let's see if he's doing that. Okay, his receive prefix is here, 0 here, but that's fine. Let's see if router 3, New York 3, the core. Okay, he is learning these from, and they have 200. Good. Perfect. That's what we want. All right. So we're getting somewhere here. So we have routing this way. Now we need to check the reverse path. So let's take, for example, New York 3, NY3 is a loopback. Is it being advertised? Is it reaching Miami. So let's just do it. Let's go to Miami 3. Let's just start at the end and let's assume we're getting the good bits today. Actually show no, we're not getting it. Okay. All right, so I think what's happening most likely is we have the routes on MY1 and 2, but we're not advertising them this way. So let's see how we want to do that here. Yeah, I think what we want to do is redistribute EIGRP this way. I think that's what we're missing here. So let's go to New York. Show run section BGP. Yeah, let's do that. So router BGP 6504. Let me think about how I want to do this. Probably a route map. I could do yeah, let's send them all that way. Let's see, we don't need that description. Router, neighbor. Yeah. Yeah, how do we want to advertise these routes? Do we want to do an aggregate route? Let's see what our address space is. Show IP route. So we've got a 10. A lot of 10s. And the only thing we're advertising right now are, we've got a few network statements for the point-to-point links. That's it. Yeah, I think I just want to redistribute EIGRP. Router BGP 6508. Oops. And redistribute EIGRP 100. Actually, let's see. We'll use the default. Okay, let's do that on router 2 as well. Router BGP 504, address family or uni, redistribute EIGRP 100. Let's just make it simple. Okay, so now we should be sending these to into the MPLS cloud. Let's just take a quick look at that. Show BGP IPv4 uni. Summary. Show BGP IPv4 uni neighbor. Advertise. Okay, good. And next hop is the iBGP loopback. All right, let's see what it looks like at the other end. So let's go back to Miami and show IP route. Let's do a show IP route. Okay, now we're learning a lot of routes here from the other end. 10 to 10s. We could probably do some summarization, but we're not going to worry about that at the moment. There are the loopbacks. Okay, good. All right, so let's go to the core down there in Miami. Going to Miami. 3.3. Boom, we have reachability. Awesome. Okay, so it looks like our traffic, we have bidirectional reachability. So looking at our Convergence test lab here again, the Edge RP in New York is working, iBGP in New York is working. We have reachability between the loopbacks at the main office. Let me double check the loopbacks from New York. Let's see, the loopback down in Miami, 10 dot, what is it? Shoot, I don't remember. $10.45.01. All right, so let's make sure we can get there. Oops. I'm just making up IP addresses as I go. Yeah, it's just make up IP addresses. All right, let's do a trace route. And let's watch the pretty packets take their little trip. Trace routes sometimes run slow on this platform in viral. Sometimes they can be very slow. Reachability between loopbacks to the main office and remote office. Got it. And the other thing we want to do is we should expect to see in Miami, from Miami to New York, equal cost multipath routes installed in the routing table. All right, yeah, this is taking a little while here. All right, so let's go into router 1. Okay, this is using ECMP as well, so that's good. We see we've got 2 entries here. That's because we've got Ceph entries for multiple Ceph entries. So, yeah, it does take a while, huh? 16 milliseconds, 5. All right, so we're in the phase of validating our build right now. 1.21, who is that? I would assume this guy. Let's just see. Almost forgot about my coffee got sitting over here. Yeah, I don't normally drink coffee this time of day, but, you know, when you're labbing. All right. Okay, so here's our MPLS labels. That's good, 1931. It's taking a while, isn't it, guys? All right, by the time that finishes, I'll probably have solved the lab. All right, so I think we validated the build here. We've got our basic configuration ready to go to test. So let's go back into our problem statements. So again, we're having issues with this end of the MPLS provider, the provider service. In particular, we're going to pick on this side, right, this leg. And as mentioned before, the management team has challenged, IT management has challenged the network team to better leverage redundant paths to minimize the impact of an outage. Let's even make it more like executive level. To business units. If you don't have business units in your problem statement, then you don't have a problem, right? So I think we want to attack 2 scenarios here. Okay, this finally finished. And this is what we expected, right? 6508, good. All right. Oh, we did want to check one more thing. Miami 3. show IP route BGP. Actually, these will be all, okay, so notice we have equal cost routes here. In particular, let's do, yeah, we've got equal cost routes. Good, that's what we want. All right, so our first scenario is an indirect physical link failure. So as we mentioned before, that could be between, for example, Miami 1, the CE, and the PE router, where we're going through a fiber switch or a repeater or a media converter of some kind, and we've got a link light on Miami 1, but there's some sort of problem at layer 1 or layer 2 between the PE and the CE router. Okay? The proposed solution for that, and again, only certain things are under our control. Now, what I could do is, and let's divide these possible solutions into a couple categories. One is with service provider cooperation, or with service provider let's say with service provider agreement. In other words, we propose a solution, they agree to do that. For example, I can think of is, well, both of these probably fall into that category, with or without the service provider's agreement. For example, the hold timers. This is one thing that we could potentially do, is reduce these hold timers on the BGP session. And that's something we explored yesterday. We have some good packet captures, by the way, guys. If you're not familiar with the channel, there's a Google Drive link in the below. And in the Google Drive link, we have links to most of the packet captures that are done in these different labs for reference. But one of the things that we came up with is that we can reduce these hold timers in BGP. We don't have to have the full cooperation, but it's always better. And the reason is we can try to negotiate a lower and lower hold time, but there is a possibility that the PE router will limit what we can do in that regard. And I want to emulate that. So we're going to assume that the service provider limits the hold time to, let's say, 45 seconds. And let's see what we have. I think we may already have that configured. Let's go to the PE router, which is here, Verizon Miami 1. And if we go to this router, there you are. Show run section BGP. Just checking something here, guys. Okay. All right, so as we see here, nothing is configured for the timers, but we're going to configure this timers as if you would assume that as a service provider that they're going to limit, they're not just going to let you hammer their device with timers over and over. With keep alives is what they're called in BGP. BRF VPN underscore 65508 neighbor 231.1.34. I don't know if they can do this globally or not, or do they have to do this per neighbor? So timers, we're going to say, I doubt that they will go below. They will probably have the defaults here. 60, 180, and the lowest hold time that they will allow is, we're going to say 45. So this is, now if we have cooperation, or if we have agreement with our service provider, we can negotiate a lower timer that they will allow here. So let's say that we have negotiated, assume negotiated to 45 seconds, right? The other option is BFD. And again, in this case, obviously it would be better if both sides are running BFD, but it's highly likely that they will not. So in that case, with agreement, both routers using BFD. Without agreement, one side BFD. And that's what we want to try here. That's what we want to test. So we're going to test BGP timer. Test 1. Lower the BGP hold timer. That will address scenario 1. So this is scenario 1, right? And this is also under the heading scenario 1. Okay. We're not too concerned about the adjacency here, because again, this is just a feeder router, right? We're mainly concerned about this adjacency here. Although we are going to talk about a potential failure of a link here and how we want to handle that. Okay. So test 1 is to lower the BGP hold down timer. And test 2, single router BFD. How would we ever see your mouse pointer without the big red circle? Exactly. And I can't see your name. Loot hacks. Yeah, I saw that. I got this idea from someone, actually, another streamer. And man, I need to make my mouse big. Like some of these things on my screen are exaggerated. Typically, I use small text, but just because of the nature of this, and I've watched some of the programming channels too, and you see like really small text, and it can be hard to read. But yeah, try to make it easier for folks to see. So test 1, again, lower the BGP hold timer. We actually did that test yesterday, so I'm not going to go too much into that. We are going to, what I did not test is a difference in reachability. So I would like to test that, because yesterday we did not have a router here, New York 3. So we didn't have redundant routes. So we configured this yesterday, but we need to test it. And I'm about to do that. This is not a scientific test, of course. These, of course, aren't real routers. These are just test routers, virtual routers. But we're going to just load a simple timer here. Online stopwatch. And we're going to do a before and after. So with default timers, BGP timers. And Safari's been acting up today. I do not know why. It will do that sometimes. All right, let's see. Online stopwatch. There we go. Okay, so what we're going to do is we are going to basically we're going to shut down a port here. the interface will still show as up on our router. And we want to test how long it takes for convergence to happen. All right. So let's run a ping from Miami. I think what I need to do too is I need to set this path as preferred. Because right now we're doing equal cost. I need to actually prefer the route this way. So we're going to make this route from Miami to a little less attractive, just for the purpose of our test. Let's go to Miami to show run section. And this is in EIGRP because we're redistributing BGP into EIGRP, and we're using a metric, and we're going to modify that metric. Yeah, as a matter of fact, we're going to modify the bandwidth metric. So let's say router EIGRP 100, and let's change this metric here. As you can see on the core, we have multipaths, right? We have equal cost. Here's the composite metric, for example, for a lot of these is 537856, but we're going to make that higher. We're going to say this is, how about 9, 5. See, is that right? 10. I got to count my zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah. Let's make this 9, 5. Okay, clear IP route star. We're going to do the same here. And show IP route. Okay, now we only have a single route to that location, and it's going to be through this router. Okay, let's check though to make sure that what we want to also have going in EIGRP is that this route is still marked a feasible successor, so that it will quickly install that route in the routing table when we lose this route. Show IP EIGRP topology. Okay, our feasible distance 537856. And this composite metric is 539136. Okay, this is listed as a feasible successor here. Let me make sure I've got this right. The feasibility condition 537856, 537. That is a little higher. I don't feel real comfortable with that, so I'm going to lower the redistribution. I'm going to lower the metric. There's a little bit of trial and error, but I think the other day I tried this, and if we do 9, 9, you can actually do it too low to where the composite metric is still the same. Okay, now that we passed the feasibility condition. But we only have one successor route, one feasible successor route. Okay, that's what we want. So now let's get our timer ready, and we're going to kill this link on Verizon Miami 1, which is over here. Okay, interface J0133. All right, so let's start a timer. Well, let's start our ping. We can actually just measure this by number of pings lost. That might be easier than trying to do the whole timer thing. Yeah, we'll just keep it there just for grins. Just for grins. We're engineers, right? We like our numbers. Ping 192.168.3.3, repeat. Okay, so I am going to hit the kill switch here. Fun to break stuff, isn't it? We don't get to break stuff enough. Okay. So now we've got, we're starting to lose packets. And the reason is because BGP is still going to be up. Show BGP IPv4 uni. Okay, see, this is still, it's still up. And we're still dropping packets here, and we're almost into a minute. So as of right now, if you're a user in Miami and you've got a call going, your phone has not reset yet. You know, if you're running a remote desktop session, things are starting to happen, right? Your screen is starting to freeze. But EIGRP is still, if we look at it, as a matter of fact, man, I should have done another. That's okay. BGP is still up, I'll bet. "19 minutes and 13 seconds. So we still have not timed out. And the other day, I think I did this, and it was almost like 4 minutes. So yeah, by this time, 1:46, your computer's having all kinds of problems. You're not happy. There's a line at the bathroom now. People starting to gather around the water cooler. They're out taking a smoke break, or like the network's down again. Someone might be slamming their monitor down. You get the picture. Yeah, this is still up. So that's not what we want, right? I mean, this is what we want to reduce. This is the problem. This is why management is needs the problem solved ASAP. Man, we're going on about 3 minutes here. I know this is riveting, guys. And if you just joined the stream, what we're doing is we are building our own lab and emulating an outage and trying to determine how to minimize the downtime. What features of BGP and other protocol convergence can we use to minimize this downtime? As we can see here, this BGP link is still up. We've got a little timer running. We're dropping packets. We have another path. We have 2 legs out of Miami. We dropped this one, but because BGP is so slow to converge, our users or machines they're dropping connection right now. They should be going out this way, but they're not. So that's what we're kind of doing a test here, before and after. And this is still, he still thinks is up. If we do show BGP IPv4 neighbor, hold time is 180, last read 232. So we should be about to hit our hold time. We have not hit it yet. 4.5 minutes. So obviously that's not going to work for management, right? Let's see, we should be about to hit the timer. 2:45, so another 15 seconds. I would expect after the BGP hold timer expires that EIGRP will immediately use the other route. Immediately is a, I use that term loosely. All right, 5 minutes, folks. People are mad. 2:56. We should get a message here in a second. Hold timer expired. There it is. Boom. Yeah. As soon as that hold timer expired, we got reachability again. That was about 5.5 minutes. That is not acceptable. So the first thing we're going to do is we're going to change these timers. All right, the BGP hold down timer with default timers was approximately 5 minutes. Result 5:30. We'll say 5.5 minutes. All right, let's change these timers. Let's see what happens. Router, BGP, let's see. All right, so we're going to go here to this neighbor statement. Router BGP 6508, right? Yep. Address, family, IPv4 unicast, neighbor 192.31.133. Timers. Maybe it's underneath. It's in the global mode. Yeah, it is. So we're going to do keep alive interval of 15 and a hold time of 45. And we're going to bring the link back up and see if they negotiate. All right, you're done. You can ping later. 97%. As we know in networking, 97% is a really bad number. That's a horrible number in networking. So let's go to our Verizon router. Unicast VPN, base remove session interface. Yeah, it took forever. All right. Interface jazz 0133, no shut. So link should come back up. BGP should come right back up. And let's see what our hold timers were negotiated to. Okay, now the hold time is 45 seconds. So that should help. That should help a lot. As a matter of fact, let's get our timer ready. We're going to do the same thing. And we're going to document this with BGP default timers now with hold time of 45 seconds. Result. All right, let's go to our Verizon router. Let's get ready to, let's do our ping. And let's go to our Verizon router and shut that interface back down. Okay, so we're running our test. Users are like, man, the network is down again. Yeah, users are not happy by now. And I need to change this chat window so it is in dark mode because I just realized it can be otherwise much more difficult to see. All right. I appreciate the viewers. Edit appearance. No, it's not what I want. There's all kind of stuff you do with this, man. I'm still learning. Where is the dark mode? Oh well. A small window too. Close that. Ah, here we go. Nope, still don't see it. Okay, let's check on our convergence here. Okay, 33, so yeah, this is interesting. The timing here in the virtual environment, we passed way more than 33 seconds. You almost have to double it in real time, it seems. Probably from what you'll see in the real world. And now I have really messed this little window up here. Move that off to the side for now. Clear. Okay, notification sent. We should be routing now. So, you know, half the time, basically, which is predictable. That's pretty much the outcome we expect. So we can only do so much there, right? Because again, your service provider is not going to allow you to send keep alives every 2 seconds. But that already is a huge improvement, because if you can recover, if a machine or a phone call or a remote desktop or viewing session can recover in that amount of time, that is a recoverable, that's more of a recoverable outage. Especially if we're talking about real time, 45 seconds, we're in much better shape. So we tested that a little bit yesterday. What I really want to test today, though, is BFD, which I've only configured once before, and I've never configured BFD on one side. And I'm very curious to how that will help us here in this scenario. So test 2 is we're going to, let's go ahead and put things back the way they were. We'll open that port. Okay. We're going to leave the timers as they are, because what happens is when you have BFD running, in particular on both routers, on both ends of the link, timers are no longer really that important, because you're no longer going to rely on the timer to determine whether the neighbor is up. Session state will be held by the BFD feature. So that's what we want to do now, is we're going to test, first I'm going to test BFD on both sides. So again, we're talking about our test solutions here. One might be with or without the service provider agreement. If we have an agreement with the service provider to run BFD, that is going to be, actually that's going to be our first test. Both routers running BFD. And then test 3, single router BFD. Okay. So let's configure that now. And I've only done this once, so I'm going to kind of try to go by memory here. And still, there we go. I was able to get rid of that stuff in the chat window, so it's coming back here. There we go. Good deal. Hate to miss a chat. And we configured on the interface. You configured on the interface and in the routing protocol that you want to utilize the feature. So in this particular case, on Miami 1, we're going to configure it on the interface, of course, facing the PE router. I don't remember right offhand, so Okay, there it is. Interface Jazz0133. And all it is BFD interval milliseconds. 50 is a minimum. The lower end, we're in a virtual lab, so I'm just going to be a little more conservative. You can't notice we don't have the carriage return option here, so we still have to keep going. Min Rx is going to be 100 as well. And the multiplier, looks like we have to add that. Values to multiply the interval, we'll say 5. Okay, we're going to apply this. Okay, it is applied. We're going to go to the other side as well and do that. Now this, I'm not sure how this works when you're using sub-interfaces. I would assume the same because this works for Ether channel. Okay, yeah, this is sub-interface. Show run interface Jazz0133. Okay, it's doing VRF forwarding, but shouldn't matter. So we install it at the interface level, and now we need to install it at the protocol level. And I think I just watched a video on this today, so I'm going to go by memory here. I think we just go under the protocol and global configuration mode. No, in BGP, it's at the neighbor level. That's right. Router BGP1, address family IPv4 uni, VRF. And we're going to say neighbor 192.168.134 BFD, or fallback. Is that right? Fall over BFD. Okay, and now this is interesting. We can't hear, say it's either single hop or multi-hop. I believe it defaults to single hop. But multi-hop is probably a lot more complicated and not something we want to do in this particular lab. Okay, so now BFD should be enabled. BFD session created. And we've got one-sided. Let's go ahead and put it on the other side, Miami 1. Router BGP 508. Yeah. And actually, I need to see the output. So router 508, address family PV4 unicast. Just trying to get in the habit of doing unicast. I'm about to hit multicast, so I'm going to thank myself later for doing all this extra typing. 33 fall over BFD. And I'm going to do a packet capture here because I have never done, I've seen it on video, but I've never done my own packet capture for BFD. So let's go and do that. And we're going to do that on Miami 1. Jazz01. Traffic capture, just going to capture all traffic. Okay, and it's created. Let me move that screen. Yeah. Okay, BFD session is up. And now let's do our same test here. It should be pretty much immediate though. As immediate as you can get in the virtual environment here. But now if we go do our ping and we come over here to Jazz01, was it 33? Yeah, now if we shut the interface down, let's see how fat. Boom. We only lost. That is awesome. All right, so that is BFD running on both routers, both ends of the link. Now we're going to mix it up here a little bit, and I did see a little bit about this in a video, but I'm not sure exactly how this is going to impact the network for a couple reasons, and I'll explain those in a moment. As a matter of fact, in order to do this properly, okay, I'll explain that in a minute, but this is going to be a little more subtle. So let's bring the interface back up. And let's remove BFD from the PE router. Okay, we're going to remove it here. I'm going to remove it from the interface too, because we are going to be analyzing the packet captures later. So no, you can't just do no BFD. Do show run. Okay, admin down. Show IP BFD. Oh, we have one session and it is down. So what is going to happen in this case? Will the router resort to hold timers? Or will we drop it on one side and not drop it on the other side? All right, and here's how this scenario, to me, there's some doubt in my mind as to how successful this may or may not be, because you've got egress and ingress traffic. So let's say I'm running BFD on one side and I'm getting my packets back, and I detect a link failure immediately on Miami 1. That's great if you're in Miami and you're sending egress traffic, because we will immediately start to use Miami 2 for all our traffic. The problem, though, is the return traffic. That's what I'm not sure about, because if this means that the PE router is not running BFD and does not detect a physical link failure, then he will not issue a withdrawal for these routes. And I think we're going to have packets dropped on their return. That's my theory. And why BFD would not be advised in this particular case. So in this, it's immediate, right? But in order to properly test this scenario for the return traffic, I want to ensure that return traffic is preferred out of router 1, kind of like we have it in Miami, preferred out of Miami 1. We need to go back to router 3, and there's a couple ways to do that, right? One way to do that is to advertise these routes out of router 2 with the longer AS path. So why don't we just do that? Let's go to NY2. Let's see, NY1, NY2, right? Yeah. Show run section BGP. Although I think we're stripping the AS. Yeah, so on the PE router, we are doing an AS override. So another way to do that, yeah, let's just see how that works. I need to become a little more familiar with that process anyway. That's part of this lab, part of what I want to do with this lab as well, is get a sense of the return traffic and how that is treated by the MPLS cloud. So Let's try that first. Let's try adding the AS path to NY2. Actually, something I need to do before that, folks, and let's back up a little bit. The build requirements is that we want our VPN v4 routes to also support multiple paths. So we want our service provider to support multiple routes. So I'll have to refer back to some information on how to do that. I don't know right off the top of my head, but I believe I can find it, hopefully relatively quickly. Yeah, we need to back up to that. And Safari is running really slow right now. So let's just go to cisco.com. I'm going to try to do it the way I should, right? By using the documentation. Network software 15.6M. And config guides. IP routing BGP. And let's see, no, that's not it. Multipath load sharing. Yeah, here we go. And I've done a few labs on this. Max pass IBGP. Yeah, controls the maximum number of parallel IBGP routes that can be installed in a routing table. Now that will, and that's fine. We basically want this to happen at in our particular topology, I think the only place we need to apply this is at the route reflector server. He needs to have two paths in the routing table. So for example, right now, if we go to the route reflector, he should receive a route, for example, 1045.00 from NY1 and NY2, a VPN v4 route. And if we look at his routing table, he's only going to choose one as the best path, right? So that is something we need to fix. Where are you? There you are. This is our route reflector. Yeah, so he's got 4. And I believe our communities are set up correctly. All right, let's just let's look at this. So if we look in the routing table right now, show VPN v4 uni all. Yeah, we're only using a single best path. For example, we have an aggregate route. Or we should. Yeah, here's an aggregate route. And he's preferring right now router 5. Route distinguisher. 65508, yeah. 65082, that's right. These are using different route distinguishers. And let's make sure that 6504, sorry. This is 65504.1. (65504.2). Okay, this is coming from Miami. Yeah. So the thing is, Yeah, I wonder how this is going to impact the fact that they're using different route distinguishers. So let's say, for example, what is he going to advertise to New York 1? Show BGP, VPN, v4, summary. I need all. I always forget that. Okay, I forget which one is which. Prefix received 10.8.17. Okay, these must be Miami. Let's check. So this is New York 1. Show. I should have these labeled. Okay, this is. Oh, Verizon New York 1. That's what I need. There you are. Okay, 7.7. All right, yeah, I think it goes 7, 8. Right, 3, 5, 7, 8. Okay. So what is it going to advertise to NY1? Because NY1 should be set up to receive both communities. And we've got a new follower. DeWiro, hey man, welcome to the stream. Glad to have you, my friend. Glad to have you. Do a little routing here, trying to break some routing stuff. So yeah, let's see what he is going to advertise to 7.7. First, let's check his BGP configuration and which communities that he's going to allow in. Okay, send community extended. Show IPVRF. Hey man, I'm glad. It wasn't long ago. This is way over my head too, so don't feel bad. Still a lot of it is. Okay, 655.041. I think the receive is on the CE router, right? No, it's here. It's here. I forget where that is. The route distinguishers. Okay, here it is, under the VRF. I thought I did a show run IPVRF. All right, anyway. So yeah, we can import any of these. 65508, 1 or 2. So question is, router 6 is probably only sending us 1. So let's go back to router 6 and just see. Show BGP, VPN, v4, uni, neighbor, uni all. Yeah, neighbor 192.168.7.7 advertised routes. Okay, so it's sending both of them. He is sending both 6508 and 6508.2. So maybe it is on the it must be here where we have to make the decision which route we're going to advertise to our neighbor. Which route is the best path? Let's look on these edge routers here. So we're going to go to Verizon New York 1. Show BGP, VPN, v4, uni, all. Yeah, so he's only installing. Okay, 6.5. All right, now what does he advertise? Show BGP, VPN, v4, uni, summary. show BGP IPv4 uni 192.168 neighbor. Is that right? Yeah, 192.168.6.6. Advertised routes. No, sorry. Show BGP IPv4 uni neighbor 192.168.18. Advertised routes. I need to do VPN v4 here, don't I? Even though all, man, I always get this. There we go. So yeah, he's only advertising route 65041. So he's receiving 2 copies of the route in 2 different route distinguishers. And he is sending he's only sending the one from router 3. So I wonder what the tiebreaker is for that. Man, this probably goes down to like router ID. So how do we tell him to send 2 routes? I think what we need to do is configure maximum paths, right? So this is, in this particular case, this is eBGP. So we want to do eBGP multi-path sharing, load sharing. Yeah, multi-path load for both eBGP. This is what we want right here. So we have a service provider BGP MPLS network. We have provider edge router 1, provider edge router 2. That's not really our scenario here. We're single homed. Okay, here we go with route reflectors. Provider edge router 1, 2, 3. Yes, this figure the 3 and all configured. Okay. For all equal paths, preferred paths to be advertised through the route reflector, must configure each VRF with a different route distinguisher, which we've done. Prefix will be recognized directly and advertised PE router 1. Yes. Okay, we've done that. Oh, okay, that's right. This is what we need. Router BGP. We need EI BGP. That's what we need. Follow shows example. Select 6 routes as multi-paths. Okay, this is what we need. I knew it was max paths, but I did not think about the fact that we really need to do both here. And we also need to do this. Let me think about this, though. So do we already have... We should already have, we do already have multicast or ECMP running. Let's go to New York 3. Show IP route. Okay, we've got it. So we're already covered there. The fact that we already configured, we do have multiple routes supported. Yeah, we have multiple routes already, and the fact that we are using different route distinguishers. Unique route distinguishers. So we're set. All right, now we're ready to do our test then. We're going back to using under scenario 1, test number 3, single router running BFD. So here's my fear, again, as I mentioned, that if we lose a connection here on one side of the physical link, and we have BFD running, that we have BFD running this way. Let me draw this out. Let me just draw it. So we have a link here, and then we have, let's say we have a media converter, for example. Okay, and then we take one side down. Do those red. Okay, we take this side of the link down. This link looks like it is up. So with BFD running on this router, we should immediately shut down BGP and begin routing all our traffic egress through Miami 2. The question, though, is the return traffic. So the return traffic should come through here. If we're going to set the preferred routes to be this way, and he's going to want to go to router 3 as the next hop. Which one is router 3? Let's see, because that's where we'll probably go now. $658.2. Yeah, that's going to be. So he's going to prefer to go this way right now. We need him to prefer this router. But see, in a real world scenario, aside from any other traffic engineering that is being done by the service provider, which we're not going to see, like maybe this is off net. Maybe they're going this way because, they might have traffic engineering configured. This is random right now, but this is off net. So they might give a preference, unbeknownst to us, to send traffic this way instead of that way. We really don't have any administrative control here, right? So the chips are going to fall where they lie. Right now, it looks like the return traffic will come back this way. Let's just double check that is the case with these router numbers. I need to label those. On this side, Miami 2. Well, it's the Miami Verizon router. Here it is. Okay, 3, yeah. Let's find a route that's going to go the other. Well, they're all going to go this way, aren't they? All right, let's switch this up. Let's move the test to the other side. And what I mean by that is we're going to change the preferences so that we're actually going to shut down this link. And let's see what happens. So let's go back over here and adjust our redistribution metric. Show run section BGP. Actually, it's under. Yeah, it's under EIGRP. Okay, so we're going to change this. And we're going to put this back to the default, or what we had configured as the default. And we're going to put this metric over on the other router, router 1. We had a 95 instead of 100. It's 95. Yeah. Okay, so now routing should be preferred this way. Let's shut off BFD over here as well. If it's configured, I think it is. Show IP interface brief. No, Spotlight, go away. Go away. Okay, so we turned it off. And we're going to change our packet captures because we're going to the other side. We're going to stop this one. Download. And stop. That's going to be our two-way packet capture. Then we're going to have a separate one-way packet capture. One-way BFD packet capture. And remove that. Yes. Thank you very much. And we're going to start a packet capture over here on router Miami 2. And we're just going to capture everything in all its glory. Capture everything, filter later. I always say. All right, so Miami 1 done. Now we should, let's just validate that the core will prefer the route through Miami 1. EHRP, yeah, we have a single route and it's going through dot 6, which should be that way. Okay. We'll delete this business. We'll worry about that later. That has served its useful purpose. All right, so now router 2, we're going to put BFD over here. Show IP interface brief. .37 BFD. Do I still have it in here? Awesome. Look at that. And show run section BGP. Capture is running, yes. Okay, and yeah. Router BGP 6508 and address family. No, it's under the global mode, I believe. Neighbor 192.31.137 all over BFD. Okay, so we've got it running one way. And I'm not sure if it will even be used, to be honest. Not even sure it will be used. Now here's a question though. How do we really truly emulate an outage? If I shut it down on this side, BGP will terminate, it should terminate the session right away. And that's not what we really want to emulate. We really should have a switch here to kind of emulate this. And how else could we do that? Yeah, we really need a switch here. All right, well, first let's just test the BFD feature. We'll shut down this side of the link. Maybe that's something we could do tomorrow. That would take too long right now to reconfigure the lab with a switch there. Okay, Verizon Miami 2. Jazz 01. What was it? Jazz 0137. And let's do our ping. 192.168.3.3, repeat. There we go, shut. All right, let's see if he detected it. BGP IPv4 uni summary. Yeah, it's still, look at that, it's still up. So BFD on one side doesn't really do any good, apparently. We're going to see what the packets look like in the capture. We're going to analyze those later, but yeah, it doesn't appear that it really does any good. Ping wants to... Yeah, so we can't ping it. And BFD... Yeah, I don't even... It must not even be sending packets. It's not. Well, that answers that question. So let's do this. That's kind of a bummer. No, yeah, session change. See, it changed here, but it just did not change. Okay, then it came back up. All right. That wasn't as long, though. Oh, it did destroy the session. Interesting. BFD session destroyed. That took a long time, though. Let's do debug. Let's do that again. Let's do it with our timer. Apparently that did work. Theoretically, it's supposed to work, at least for one side. All right, what am I doing? I'm clicking between routers here. I think I want to come back here and do a no shut. Okay, BFD session created. Okay, so it is working then. That's good. All right, let's do that again. Let's go back to our ping. Yeah, we didn't lose much time at all. And let's go back to our upstream router. And we're going to do a shut and start. And let's see how long that takes. Yeah, BFD has still not marked him down. Wouldn't expect it to take that long, though. 1 minute. Timers are probably at the defaults, which is 3 minutes. How many packets do we have there? Okay, we got a few more to go. Question is, if we go to NY3, yeah, he can't reach him. Yes, he has 2 routes. As soon as that triggers an event, okay, how many dots we have? We're about there. There we go. And right away. So, good test. 225. Maybe that wasn't BFD at all. Let's look at our hold timers. What are our hold timers set at? Decreasing credits by 12. You just lost some credits, man. Okay, so this has lower timers. $20 and $60. That was left over from yesterday. Still, I think that was BFD taking action there. So, single router BFD, we're looking at 225. Okay, now I want to terminate the link from this end. So let's do this. Let's go back to the Verizon router. Do a no shut. Let's put those timers back to where they should be. On router 2. Router BGP 6508. And no neighbors. Okay, we're going to set it to default timer. We're going to do clear IP BGP star. Okay. Now what we're going to do is we're going to shut down the link on this side. So this should immediately start going egress this way, but what will be the return traffic? The result of the return traffic coming back. That's actually a better test for what I'm trying to figure out here. Test single router BFD, shut down PE link. And then test 4. This will be our last test of the night here. Single router BFD, shut down CE link. Okay. Reset. Move that. And let's make sure we have show IP route, or actually show undebug all. Show BGP IP4 uni summary. Okay, we're good. All right, so we're going to run our ping again. And this time we're going to shut down the link here. BFD is running, but I don't think that will matter at all at this case. In this case, I should say. All right, ready, go. Yeah, BFD session destroyed. Boom, we're down. Okay. So now we should have, it's going to be the return traffic that's having a problem, right? So if I trace route right now, 192.168.3.3, we get to the other end and we can't come back. Who is 1.33? Yeah, because we have not flushed the route yet. this router still thinks we're up, and it's going to take 4 minutes to... Okay, that's what I suspected. So what I'm thinking is, and this may be a part, I may continue this whenever we cover, I think it's IP services, and we do IP SLA. But really, as far as reacting to something inside of this cloud, again, this cloud is out of my administrative control. There's not much I can do here. So what I have to monitor is endpoints, right? Sure, I can monitor the physical link here, but I have no control how these routers are going to react. But if I can base routing, now a couple of proposals here. And we'll just wait for this time. I mean, I'm still going to kind of talk, but so in conclusion, convergence improvements are limited because of a lack of administrative control in the cloud. So additional, there we go. So still took a while. Did we have timers set on that router? Is that why it was faster? Show run. That's why. Okay, that would have been triple that. So that really would have been, you know, in both these cases, this would have been, we're going to say, normal circumstances. Well, we're using BFD here. This BFD had no impact, so I'm going to say it would have been like this, 530. So basically, additional solutions or proposed solutions in order of simplicity or in order of least complexity is we can basically do and again, I haven't studied IPSLA yet in its entirety, but I would imagine, I know we can base routes on tracked objects. I wonder if you can base a BGP neighbor session, bring it down based on a tracked object. But that is somewhat more processor intensive. And has its own problems. But essentially, we're looking at SLA to where we're monitoring, you know, should we, you know, we're importing these routes here to Miami. Can we do that based on object tracking? So, in other words, if I see, for example, I'm not sure what I would track. Maybe, you know, reachability. Yeah, I'm not sure. That is one. We have to study that some more. IPSLA. And track and object tracking. The other one that would be complex change. Not extremely, but that would be basically removing some of the policy control from the provider by changing our routing policy between these two sites with DMVPN or tunneling. So in that case, which I just learned about, you know, went through that in the workbook, we could build tunnels here, and we could establish adjacencies, routing adjacencies through EIGRP, for example, and rely on the convergence of EIGRP as an overlay to the cloud, and that would give us the most amount of control, right? Then we're just using the MPLS cloud for pure transport. We're not relying on any routing through the cloud for policy, simply for transport. And that is ultimately what we might have to get to, but we're going to explore this first. Probably not tonight. By the way, I'm going to stop that capture and we'll take a look at it. Yeah, this is going to require some time to really go through this, but we'll take a quick peek here on the stream. But yeah, that will be future labs, right? We'll come back to this topology. We're going to save this topology. I'm going to do a write mem. Let me clean it up here a little bit. We got to do some cleanup. Let's just check the BGP session over here. We got to clean up redistribution. Yeah, this metric needs to change. And we're going to put this back to where it was. That's what I forgot to do last time, and I paid for it. And okay, we're going to take this out. Router BGP 6508. Huh, that was still running over here. He wasn't doing anything though. Show run section BGP. Yeah, we're going to take this out as well. Save here. We're going to look at this router to make sure BFD is now running and the timers are good. Yeah, let me just go ahead and close the stream out here, folks. Tomorrow we might take a look at these packet captures, and I'll probably just stop the stream and stop the recording and do this cleanup. So you have to, you know, nothing interesting there. But yeah, thanks for joining. And if you haven't already, please follow the channel and Twitch, or if you're watching this on YouTube, and check us out on Instagram, Facebook, Discord, and of course on Twitter. And all the links are below. Appreciate all the support and the feedback and the chats. But happy labbing, happy learning, and hope you get all the good bits. We'll see you back here tomorrow.